volume of this solid iron pole is volume of the bigger cylinder plus volume of the smaller cylinder. I've indicated the radius and heights of the cylinders as R1 H1 and R2 H2 because they are different in dimensions. So R1 is given as 24/2, 12 substituted here, and R2 is 8 centimeters, and H2 60, and H1 is 220 substituted here. And then we have done the simplification. Now this product gives me this much, and then we proceed with calculations, and if you want to convert, you can convert, or you can just leave it here, this in terms of grams per centimeter cube. Or what you can do is you can also write this in terms of kg per centimeter cube. In order to do that, what we do is, we know that 1 kg is equal to 1000 grams. 1 kg is equal to 1000 grams. Now this entire value, when I multiply by 1000, I also need to divide by 1000 because it's I'm not given the power to change this number. But what I can do is I can do some alteration such that this remains the same. It does not alter. So this value is gram per centimeter cube 1000, right? Multiply by 1000 and divide by 1000. Now 1000 grams is nothing but how many kgs? That's 1 kg. I've written here. So this can be written as just kg, and this is 890.264 3 zeros. Place the point from right hand side after 3 digits. 1, 2, 3, 890.264. 1000 grams is 1 kg. So 1 kg, that is 890.264 kg per centimeter. Next question in exercise 13.2, question number 7. In this question, water is placed inside a cylinder. This. We'll draw the diagram first. Water is filled inside the cylinder until this height from here. Now, a top, a solid in the form of top, which consists of combination of cone and a hemisphere, and height of the cone is given as 120 centimeters. I'll draw a cone. Now, this object has water inside of it, and I'm placing a top like this, right? I'm placing a top inside of it, and the water flows out. And what we have to find here is, after placing this toy or this top inside this container, what is the volume of the water that remains inside this container? So this is the top, how it is placed. This is how it is placed. Height of the cone is 120 centimeters. Height of the cone. The radius of the hemisphere is 60 centimeters. This is given in the textbook. This length from here, from this point to this point, 60 centimeters. And height of the cylinder is given as 180 centimeters. From height of the cylinder, here this point to this point, so 180 centimeters. And find out the volume of water that is remaining inside this container after placing this solid object. Volume of the cylinder minus the volume of this object gives me volume of water that is contained in the remaining water that is there inside this cylinder. So volume The question is, we have to find out volume of the water that remains inside the cylinder after placing the solid object. So volume of water remaining, water is equal to volume of the cylinder minus volume of the cone minus volume of the hemisphere. Minus hemisphere. HS stands for hemisphere. Let's substitute the formula and the values of the H and R and find out volume of the water that remains inside the container. So volume is equal to volume of the cylinder. I am writing formula first, is given by pi r square into H. Since R is same for cylinder as well as sphere as well as for cone, I am not indicating this with any super subscript or suffixes here like this 1 or 2. I am not indicating because it is common to all three solid types. There is one cylinder, one cone and one hemisphere having all the same radius, but height varies. Okay, height varies. Let's substitute now. Okay, this is volume of the cylinder. Height is different, so let me indicate this as H1 minus volume of cone is given by 1 by 3 pi. Since R is same, R square, let me indicate H with H2 because H is different here. Height of the cone is 120 centimeters, so I am indicating that H 1 by 3 pi R square H. Volume of hemisphere is given by 2 by 3 pi R cube. Since R is same, I am writing just R instead of H, R1 or R2. This is equal to pi can be taken out as a common term, and also R square, because R square is present with each and every term. There is R square here, R square here and R square here. Although there is an additional R here which remains inside of the bracket after taking pi common out. Pi R square, this is equal to pi R square. H1 minus, I could have taken this 1 by 3 also common. Calculation will become simple. So if I take 1 by 3 common, that is pi R square upon 3 common. Now I have to multiply by 3 here, so that when I am multiplying these two terms, I get back the same term pi R square into H1. See, if I multiply this, I get back this term pi R square into H1 minus pi R square upon 3 is taken out. This entire term is taken out. So what remains? H2 minus 1 by 3 is taken out and pi R square is taken out. What remains is 2 in the numerator. That's 2 into R. This is equal to, let's substitute the values, shall we? Oh, before substituting, let us see what is H1 and H2. H1 was height of the cylinder, which is 180 centimeters given in the problem. H1 is 180 centimeters. And H2 is height of the cone. I have indicated H2 as height of the cone. So height of the cone is this much, which is 120 centimeters. (22 upon 7) multiplied by R is same for all the three solid types, solid objects, which is 60 into 60. 3 into H1 is 3 into 180 minus H2 is 120 minus 2 into R. R is 60. 60 times 2 is 120. This is equal to 22 by 7 into, I'll just write 60 square 18 times 3 is 54. So 540 minus 240. 540, that is 120 plus 120. When I take minus out, 120 plus 120, 240. 18 3s are 54. This is equal to 22 upon 7 into 60 square into 300. 20 square. Okay. So pi r square by 3. So divide that by 3. 3. This was left out. This is equal to 3 times 100 gives me 300. 22 7 upon 7, which is 3600 multiplied by 100. 60 square is 3600. I'd like to write 22 by 7 as 3.14 because 3.14 can be written as 314 by 100, and this 100 goes out with that. Calculation become easier, and there is no point here. After removing the point, we have cancelled out this 100 with the denominator 100. Now what we have here is 314 into 36. 314 into 36. Just multiply that. 6 into 4 24. 6 into 1 6 plus 2 8. 6 into 3 is 18 plus 3 into 4 12. Carry 1. 3 1. 3 into 1 is 3 plus 1 4. 3 into 3 is 9. 4. 8 plus 2 10. 0. Carry forward 1. 8 plus 4 is 12 plus 1 13. 3. Carry 1. 9 plus 1 10 plus 1 11. So that is 11,304 centimeter cube, because all the dimensions are in centimeters. So the volume will also be equal to 11,304 centimeter cube. Since 1 centimeter is equal to 10 raised to minus 2, either what you can do is either you can convert this into meters cube or you can just keep here. Okay. Another thing, we have 2 zeros here. We have left it out. So 2 zeros, because it is as good as multiplying by 100. So you have here, this is 2 zeros. So volume is equal to 11,304 cm cube. In terms of meter cube, this will be divided by 1 followed by 6 zeros. This is like this: 11,304 divided by, as I have explained previously, how 1 centimeter cube is equal to 1 divided by 1 followed by 6 zeros, or 1 million. 1 2 3 4 5 6. 1 2 3 5 6. 2 0 what? Placing the point after 4 digits from the right hand side. This gives me 1.134 centimeter cube.
Choose the right kindergarten, a right bag, and matching bottle to go with. The right school, the right friends. Choose the right subjects and score well. Be an expert in all. The right teacher, and make sure that they like you. Choose the right timing, the right bus, and take a cab if getting late. The right train, and don't stand near the gates. Mind the pockets. Better get into ladies' compartment, and make sure your mustache hasn't started coming. Choose the right study time and forget games. IPL, IHL, rock and metal, guitar, axe. The right group, and be a model to your brother. Seriously. Choose the right syllabus, the right test paper. Keep guessing questions for exams. Choose the right branch, the right college, the right stream. Choose the right career. Lucky to have a father's business to take care of and a father to allow that. the right counselor, the right form, and make sure the project is submitted on time. Choose the right website and rely on your friends for more information. Oblivious of the sites they have been to, there is no end to your woes. Getting better with every step you climb up the ladder. The summer vacation shorter, the bucket list bigger, the night darker, the books heavier. The only light you have is your friends ahead of you. Probably he is right. Ever thought how he got the direction? No more spending your energy and money on coaching classes. No more missing classes for rain, rally, and nonsense. Get your interest back in subjects through our creative ways of teaching. Doubts, concepts, applications, all explained through one vibrant animation. Subjects covered by multiple teachers with repeat telecasts. Special programs only for basic foundation and paper analysis. Personality development, career counseling, admissions, hobbies, all covered. A new approach to study with long-term perspective. So sit back comfortably in your homes and watch Study Spectrum TV channel.
Until now, we have dealt with surface areas of simple objects like cone, cylinder, spheres, etc. Also, we have also dealt with combination of different objects. We have also dealt with finding out the surface areas of combination of different objects. Similarly, we have also found out volume of different objects like sphere, cylinder, cone, frustum, etc. Not frustum yet, but different objects. Now, in this section, I will be teaching you conversion of a solid to different form. Conversion of solid from one shape to a different form. Just right here. Conversion of a solid to a different or similar shape. What I mean by this statement is, if I am taking a cylinder and which is made up of iron, and I melt it and I pour this molten metal into some cast to get a sphere. What am I doing here is I am converting this shape of the object to the sphere. So that is conversion. I could melt this and add some more material to enlarge or magnify this object, which was just smaller in size before. Now it has grown by some size or by factor. Now let's solve the problem. First problem from exercise 13.1. Exercise 13.3 based on this concept. In this question, I am taking a sphere. This first question from the exercise. Sphere of radius 4.2. centimeters. And this sphere is converted into a cylinder, just like I explained here before. A sphere is converted to a cylinder, and while we are converting, we are keeping one of the dimensions fixed. What I mean by that is, we already know what is the required dimension of, say, this radius of the cylinder or height of the cylinder. We already know that dimension, and we are supposed to find out the remaining dimension. Now, radius of this cylinder is given as 6 centimeters, and by now one thing should come in mind, that we are supposed to find h, that is height of the cylinder. So always remember, when one form of the metal is converted into the one form of object is melted and converted into a different one, the volume is conserved, which means that if I am converting the sphere into cylinder, the value of the volumes of sphere and cylinder remain the same. The only thing that changes is the shapes. Sphere has changed, or it has taken a different form now. Earlier it was sphere, now it has become cylinder. So let's find out. Let's find out the height of the cylinder. Now, from the law of conservation of volume, right? This is physics, you all know it. I won't write this, I'll just solve mathematics because we are dealing with mathematics. So volume of the sphere is given as 4 by 3 into pi r raised to 3, 4.2 raised to 3, or I can just write 4.2 into 4.2 into 4.2. This is equal to, after conversion, volume of this object will be the same as it was before conversion. This is equal to pi into r square into h. Pi into, I am not writing the formula now because by now you should already know the formula. So pi into r square into h. R square is 6 into 6 into h, that is unknown factor. Let's indicate height by h. Pi cancels on both the sides. It is present on RH in left hand side as well. So it is balanced. So cancel this. 3 times 4.2 divides 3, because 14 times 3 is 42. So this is 1.4 times 3 is 4.2. So this is equal to, this implies, this symbol indicates that this implies 4 into 1.4. 3 is cancelled with this 4.2 to get 1.4 multiplied by 4.2 into 4.2. What I am doing is, I am bringing this 6 into 6 terms in the denominator, in the RHS side, in the left hand side. 6 into 6. If you are not comfortable with the decimals, you convert the decimals into integers. You know the conversion, it's very easy. This is 14. I will just write integers first and write decimal part later. 42 into 42. This is 42 divided by 6 into 6. I will write 6 into 6 still. This is multiplied by. See, what we did was 1.4 is equal to 14 by 10. So how many such zeros are there here in the denominator? 1 point, 2 point, 3 point. So divide this by 1000. It is equal to h. Now since the dimensions are in centimeter, you get the answer in centimeter. 6 times 7 6 times 7. So 4, 14, 7, 7 upon 3 gives me h. Let's calculate it. So 4 into 14. 14 times 4 is 56. Multiplied by 7 into 7 is 49. Divided by 1000. This is equal to h. Multiply this. For 56 into 49. 9 times 6, 54. 4 carry 5. 9 times 5, 45 plus 4, 45 plus 5, 50. 4 into 6, 24. 4 carry 2. 4 5 is 20 plus 2, 25. 4, 4, 7, 2. Remember, this is not the answer yet, because there is 1000 in the denominator. So h is equal to 2744 by 1000 gives me 2.744 centimeters as the height of the cylinder. Just recapitulation of problem again now. We solved this question. Now again in short summary, I am giving you a short summary. The sphere was converted into cylinder. We had the dimensions of both the objects. Only one of the dimensions was present here, and the necessary dimension of sphere was present here. That is 4.2 centimeters is the radius of the sphere, and 6 centimeters is the radius of the cylinder. And we are supposed to find height, converting sphere into cylinder. According to the law of volume conservation, you have volume of the sphere equal to volume of the cylinder. 4 by 3 pi r cube. R is written is 3 times. 4.2 into 4.2 into 4.2 equal to pi into r square into h. That is volume of the cylinder. Pi into 2 times r, that is r into h. Again, simplifying this equation, you have h here, and then the main step here is how to avoid fractions. It's confusing. Fractions are always confusing, so try to avoid fractions and write in this form. Always division by 1000, division and multiplication. By zeros is easy. Always try to bring in as many zeros as possible, either in the numerator or the denominator. If you do that, your work becomes easy. That's how you solve. Simplify it and you get the height as 2.744 centimeters. To solving problems on conversion of a solid to a different or similar shape. Here, in this question number 2, I'm going to solve question number 2 now. We are given 3 spheres. We'll draw the diagram first. Of different radii. Radii of this sphere is 6 centimeters. Radii of this is 6 centimeters. Radii of this sphere is 8 centimeters and 10 centimeters. Now these 3 spheres are melted to form a single large sphere. Now the question is, you have to find the radius of this large sphere. Radius is what? Again, from the law of conservation of volume, assuming that there is no loss in the material, you have 4 by 3, the volume of the sphere is 4 by 3 pi r cube. 4 by 3 into pi r cube. Why am I adding volumes of these individual small spheres? That is because when I add the volumes of these individual spheres, I get the volume of this large sphere. Volume of this sphere is 4 by 3 pi into 6 cube. I'll write 6 cube plus 4 by 3 into pi into 8 cube, because 4 by 3 pi r cube. So instead of writing r cube and then substituting, I'm directly straightforward substituting the value 8 in r, 8 cube plus 4 by 3. Again, similarly, you have 10 cube. This is equal to, if I indicate the radius of this large sphere by r, I have 4 by 3 pi into r cube. Let's take the common terms out. 4 by 3 pi. This is associated with this term, and then this and this. So therefore I can take out 4 by 3 pi common. I get 6 cube plus 8 cube plus 10 cube equals 4 by 3 pi r cube. 3 pi r cube. They are present on both r edges as well as left hand side, so you can easily cancel them out. 6 cube. If you know the tables of cubes, it's well and good. If you don't know, multiply 6 and 6 first to get 36, and then multiply 36 with 6. Similarly, you do with this 8 and 10 to get 216 plus 512 plus 1000. Well, for those who did not understand how I got these values, it's pretty simple. What I've done is 6 into 6 into 6, 6 cube. So 6 into 6 is 36 and then into 6. That gives me 6 cube. So multiply this, 6 into 6, 36. Carry forward 3. 6 into 6 is 6 into 3 is 18 plus 3, 21. Similarly, you do for 8 and 10 and you get this 5, 12 and 1000. Adding all these three values, we get R cube. So that is 216 plus 512, 1000. 8, 2, 7, 1. 1728 or 1728 is R cube. R cube is equal to 1728. This figure, isn't it near to 11 cube? How do you find 11 cube? It's pretty simple. It comes from Fibonacci sequence. 11 is equal to 11. 11 square is equal to, write 1 and 1 here, and then add these two numbers 1 and 1, you get 2. Similarly, when you have got 11 cube, write 1 at both ends, add these two digits, you get 3. Add these two digits, you get 3. If you use calculator, you will get the same values. You won't get in any other than this value. It's not possible. So you have 11 power 4. You write two ones at the ends, and add 1 and 3 here, and place that value here. 3 and 3 here, and place that value here. 3 and 1 here, place that value here. 3 plus 1 is 4. 3 plus 3 is 6. 3 plus 1 is 4. That's how you do it. So I get a notion that this value should be between, like, isn't it greater than 12? Because when 11 cube is this much, obviously 12 cube will be around somewhere like this, or it should be greater than 11 cube. It's easy. 11 is greater than 12 cube. So let's find out 12 cube. If I am able to find 12 cube, if it is a perfect, now if this forms perfect cube which is equal to 12, then the problem is solved. So 12 into 12 is 144. So 144 multiplied by 12. 144 times 2 is 288 plus 144. That is 8271. Therefore, I can write 1728 as 12 cube. It means that 1728 is a perfect cube. Perfect cube. Because 12 cube gives me 1728. Right? 8, 4, 12, carry 1, 4, 5, 6, 1, plus 1, 7, 1. R raised to, now if I take power 1 by 3 on both sides, right? So I get R is equal to, this 3 will cancel with this, and R is equal to centimeters. Since all the dimensions are in centimeters, you get this in terms of centimeters. So the other thing is, if you are stuck here and you don't know how to find out the cubic root of this number, one thing that should have come to your mind is 11 cube is 1331. Therefore, 12 cube should be greater than this number. So I have tried with 12 first. If I weren't getting this as perfect cube, what would I have done is just written R is equal to 3 cubic root of 1728. Even this is fine, but if you are able to solve and simplify, well and good, or I can just keep it here.